So in this video we are going to discuss Boyle's law, its application, mathematical expression. So this is a device to calculate or to check the pressure here. Now let's look at the statement for Boyle's law. So Boyle's law means the volume of a given mass of a dry gas is inversely proportional to its pressure at constant temperature. So you have noticed the syringes. In syringe there's a piston. Given in Holi, when you use that pichakari also, you can find the piston out there. So when you compress that piston, what happens to the volume? The volume decreases. So when the pressure is more, the volume decreases. And when the pressure is less, the volume increases. So this is the meaning of Boyle's law. So you have come across the word dry gas. So what is the meaning of dry gas? That's what we are going to check. So dry gas, so these are the list of gases here. Methane gases are present here, even in stove, here, in the factories also. Okay, so this is the structure of methane. This is your carbon. The valence is 4, so 4 hydrogens will come and form a covalent bond with this. So this is methane. So dry gas means natural gases which contains 85% or more methane is known as your dry gas. So for Boyle's law experiment, only dry gas is used. So whereas wet gas means which contains some methane and also liquids. So the list of liquids present in them are ethane or butane. So these are the list of liquids present in wet gas. So the experiment is done only for the dry gas. So this is the experiment for the Boyle's law. So here are the gas molecules. You can see the molecules present here. So the temperature is always constant here. It is 300 degrees Celsius, as well as here is also 300 degrees Celsius. So the temperature is constant. It's not going to change. It's going to be fixed. So when you apply the pressure, now what happens to the volume? So this area is your volume. The volume decreases. The size of this volume decreases. So here it is noticed. You can see here. So when pressure is more, the volume decreases. And now when you release the pressure from here, what happens to the volume? Now again the volume increases. So this is the meaning of Boyle's law. So here is also another experiment. Now the number of molecules present in the gas will be same, but only the volume increases. Now look, here the molecules are moving randomly. Okay. Now once you apply the pressure, now what happens to the volume? The volume is decreasing here. So the molecules will be close to each other. Now when you increase more pressure, or if you put more weight on the piston, the volume decreases, whereas the molecules present in them will be condensed. You can see here. So this living example, you can take it for mountain climbing. Now once you go to the higher range, that means higher mountains, what happens to the pressure? The pressure is very low. So when the pressure is low, what happens to the molecules? So the molecules are far away from each other. So let's assume these are oxygen molecules. Okay, the pressure is low in the atmosphere. So the oxygen molecules are far away from each other. For that reason, the mountain climbers, they always carry a cylinder with them because the oxygen is less. Now when you go to the plains, when you go to the plain side, the pressure is very high. So the molecules, that means the oxygen atoms, are close to each other. So for that reason, it's not difficult for us to breathe in the plains. But if you go higher, they always carry cylinder. So this is your Boyle's law. So I'm going to show you actually what happens in Boyle's law. Now here I'm going to explain you the mathematical expression for Boyle's law. So this is your piston. Now if you apply pressure here, so we are going to assume this as P1, pressure 1, the initial pressure. So we are going to use it as P1. Now this is the volume. This area is your volume. So for volume, we are going to use the letter V. So V1. So initial volume is V1 and initial pressure is P1. Now the pressure has changed here. So what is the pressure now? We are going to use this pressure as P2. Even the volume has changed. So volume is going to be a V2. So according to Boyle's law, pressure is inversely proportional to this volume. Or you can use the term as volume is inversely proportional to pressure. So in mathematical expression, this is going to look in this way. V, this is the sign for directly proportional. And if you put 1 here and upon P, now this becomes inversely proportional. It means that when pressure is more, the volume is less, and when pressure is less, the volume is more. So this is the meaning of inversely proportional. So this is how it looks like. So we are going to look at the mathematical expression for them. So a certain gas occupies a volume V in liters, let's say 5 liters, 10 liters. So we are just going to use as a V1. So we know the formula. V1 is inversely proportional to pressure. So we are going to write here P1. Now to remove this sign, what we are going to do is, in place of writing the sign, we are going to put here equals to. So once you put equals to, we have to write the constant k, this is small letter k, into 1 by p1. So that's what we're going to do here. Now you multiply k and 1, we will get k upon p1, k upon p1. Now after this you have to cross multiply p1 and v1. So here I have done here. So equals to k. So k will be remaining on the right hand side. So this is the mathematical expression for Boyle's law. So p1 v1 equals to k. But here you have noticed there is change in the pressure, p2 and v2. Even for p2 and v2 you have to do it the same way. So this is for volume 2 here. The overall will be p2 v2 equals to k. This same procedure is followed here. Now overall equation, now what we are going to do here, now we are going to put the value of k. So what is the value of k here? The value of k here is p2 v2. So now our new equation will look like this. So p1 and v1 is here. So in place of this k, the constant, I'm going to place here p2 v2. So p2 v2. So this also equals to k, because the value of k is p2 v2 as well as p1 v1. So this is our formula to calculate volume and pressure. So p1 v1 equals to p2 v2. So in the numericals you will find pressure and volume given, the initial, and even the final pressure is also given, and you have to calculate the volume. So we are going to use this formula. Now I'm going to show you some of the examples or the applications of Boyle's law. So these applications of Boyle's law you can find in syringes also here. You can see syringes, and even in perfumes and aerosols, or as your spray paints, even in a football pump or cycle pump, and even in real life application. When you breathe, what happens to your diaphragm? The diaphragm moves downward. So when it moves downward, the volume of the lungs increases. The volume of the lungs increases. So what happens is, this causes the pressure inside the lungs, to be less than the outside pressure, so the air rushes in. So this is another real life application for Boyle's law. So thank you for watching the video. So I'm going to upload numericals in the next video.